Alright, now let's see a simple example of buffer overflow. In this case, we're gonna perform local buffer overflow on our local application, which is installed in our system. So just to perform on your own system, you can just go to exploit DB, from where you can download the vulnerable version of the application. And the application we're gonna target right now is the Cloud Me. So from this exploit DB, you can download the vulnerable application. You can download any version of it, but the one I'm going to target is released from this 16th of April 2018. You can go to this article here and you can download the vulnerable app from this download button, simple, and install it in the later state. Now, other than this, I have already installed it, so let's just open the application. Done. This is our application and I'm also using the vulnerable version here. Now we have multiple steps in buffer off. Let me just write down those steps here. This is the simple script I'm going to use. I'll explain the script part as well. First of all, let me just write down the steps here. So the first step that we're going to perform is the fuzzing, in which we target our application with the junk data just to check whether application is handling our input properly or not. Simple case. Second step we call it the offset detection. You have to identify the offset, which include the buffer space plus the size of base pointer, which could be extended part as well. So I'm going to write EBP, that is extended base pointer. Then we go to the third step, which is the bad character detection, or you can say bad character detection or identification, whatever you like. Now in bad character detection in a multiple application, like application, if the application is not handling the null character or end of file kind of thing, or let's say horizontal tab, vertical tab, this kind of character, if they are not properly handled by the application, then application will crash, and this will also hamper our payload execution. So what we have to do is we have to identify those bad character. For example, %00 is a bad character for the null value, right? If the application is not handling this null and crash the entire application or crash the particular function, then if our payload has that particular null value, that payload will also be crashed. It will not be executed. So main objective is to remove these null character from the payload so we can simply execute it or successfully execute it on the victim application. Simple. Now the fourth step is to identify the address where we gonna pass our payload. This address is specifically a particular assembly command, which is jump esp, and for this we're gonna use a module called Mona module, or you can also call it as Mona master. Now then the last step is the exploitation, where we create our payload and exploit the particular application for the local buffer overflow. But let's start with the first one, that is fuzzing here. Now in case of fuzzing, we have to identify where we can send the payload, right? In this application we have multiple input fields. First one is username, second one is password, then we have forgot password field as well. But instead of targeting these, I know this application is also exposing a particular port on the local system, and to identify that, you can just go to terminal, write a command netstat -o and a. This will give you a result of all the open port, established connection, listing open ports with their process IDs. But the issue is we don't know the process ID for CloudMe application. So what we're gonna do is we simply go to task manager here. We go to this app history section, and inside app history you can search for the CloudMe, right? Or if you want, you can go to this app detail section as well, and from here you can identify the application name. And for the CloudMe, the application process ID is 9012. You can see the second column for the PIDs. 9012 is the process ID. And if you scroll here or search here, we will see a process ID for 9012, which is exposing a open port at 8888. So this is the open port from the application. You can see this is the local address, this is the foreign address from where we can connect, and the local address is localhost and the IP is 8888. It means if we pass the data on this particular IP and this particular port, it will be passed to our application. That's what we have to do. So let's just set these applications first. So I'm going to use this terminal on the left hand side, and let me set it a little down here. Done. Now let me just explain this script as well. So here I have written simple Python script just to import some libraries like I've used in this system SYS, so we can execute this exit function here. I have imported this socket library so we can establish connection with the open port and open IP address, or open, let's say, any application, any domain, let's say, right? For any internet connection, we can use this socket library. Then I've imported this sleep function from the time library just to set a delay of a second. Now here I have defined a simple variable which will take 1000 A's within it. I've written simple A and multiplied it with the 1000, so we can store 1000 ones instead of typing one by one. You can use this simple method. Now here in this code from line number 8 to line number 19, it will establish a connection until unless the loop automatically closed by the exception, or the system.exit function is called. Inside here I have defined an object of the socket class. Now socket is the class, this is the particular function, and inside the function it takes two arguments. First one is af underscore inet, which defines that I am going to use address family from the internet. It means I'm going to use IPv4 address to establish a connection. The second thing is I have used sock underscore stream. Sock underscore stream defines that I'm going to use a TCP to establish a connection. If you want, you can use UDP as well, and if you want, you can use IPv6 as well with the INET 6. Simple. Now, but I'm here using IPv4 with the TCP. Then with the help of this object, I'm going to create a connection on this particular IP and this particular port. Then we will pass our chunk, which is 1000 A's, to the particular victim here. Then we will close the connection, wait for a second, then print the size of the chunk and then increment it by 50. Simple. And if we got any exception, that exception will be handled down here, and we will close the loop here and exit the application. Pretty simple code. Now let's execute it. For that, simply go to cd downloads, and here you can see we have the code as fuzzing.py. For that, just go to python and fuzzing.py. Let's execute it and let's see at what chunk size our application crash. Done. So our application is crashed somewhere between 1250 and 1200. Now it means we can see our application is not handling exceptions properly, and if we pass a chunk of size 1250 character, we can crash the application. It could be less, it could be more, but 1250 is the general value here. It could be like 1255, it could be 1245 as well, but we will figure out that in the offset detection phase. Now as we got the fuzzing data here, now all we have to do is we just need to detect the exact offset here, like what is the exact buffer size and what is the EBP. We know EBP is always 4 bytes, and all we have to do is just figure out the buffer space. But for that we have to check the headers or the registers for the memory, and to use this I'm going to use a debugger which is called Immunity Debugger. You can download it from this GitHub repository. Just open it, and from the release section you can download this 1.85 installer version. Now you can download it, you can install it, as I have already installed and downloaded it here. Let me just execute it. Let me close this one. Let me introduce the debugger part as well. Let me maximize this. Okay, let me just increase the font size so you can see it better. Font, the change, let's take it to 12. Done. So inside this, let me just add the application first so you can directly see the values as well. So just to attach any particular application and see its registers value, its ASCII code, its memory dump part, its loaded DLL files. For that, just go to File, go to Attach section, and you will see your application here. But first we have to trigger the CloudMe application. So first of all, let's go to Start menu, go to CloudMe. As application is running, make sure you don't update the application because we are targeting the vulnerable version here, so don't update it. Close, and now again go to File, go to Attach section. You will see the process ID, which is 5352 this time. Let's attach it. And one more thing, you can see the application was interactive at that state when we executed it, but now as soon as you attach it with the debugger, it moves to the post state where you will not be able to interact with the application. So if I am clicking on this CloudMe, I'm unable to take it on the top. And if I minimize this and I try to click anywhere on this CloudMe application, nothing is functional because application is not interactive here. To make it interactive, all you have to do is just go to debug section and go to run. But before that, let me explain these 4 sections from the debugger itself. Okay, this is the first section where we get the assembly code for the application. So just to analyze the command, analyze the assembly, you can just read it from this section and you can perform multiple actions. Other than this, we got second section where we can read different registers and their values. Like we can see the ESP, which is stack pointer. We got the EBP, which is the base pointer, and we can also see the EIP, which is the instruction pointer here. So in this section you can see multiple registers and their values. In this third section you can see the memory dump, like what data is loaded into the memory by the application, that you can see here in the hex format as well as the ASCII representation of the data. Now inside this fourth section you will find the multiple DLL files, multiple libraries loaded into the memory. Now after this introduction, let me just trigger the application. Let me just make it interactive so we can pass our payload and identify the exact offset. Just go to run. Now as you can see, the state is changed from paused to running and our application is interactive again. Now all you have to do is let's just pass the fuzzing data again, but instead of passing the junk this time, what we're gonna do, we're gonna create a specific pattern and then pass it to the victim application. And to do this, let me take help from a Kali module. So my Kali machine is running right here, but instead of using it there, I'm going to use it from this PowerShell. Let me just go with SSH Kali @1.30. Done. Within the Kali, you already have a pre-installed module called msf-pattern_create. Now this pattern_create will help you in generating a pattern of a particular length. So in this case, we have to generate a pattern of size 1250. So if you press enter, this will give you a result which you can directly pass as your junk. But the main point is you can later identify that what is the exact value, or let's say what are the main characters which are available on EIP, EBP, or the stack pointer. Because in pattern you can easily identify what are the particular characters at that particular location which you can use. So let me just copy this, and instead of jump we're gonna pass this one. So let me just change it. Let me remove these multiply by 1000, and instead of is we're gonna pass this one. Done. This time we don't have to loop this one, so let me just remove this while section. Done. And we don't have to establish multiple connections, so we're gonna remove this sleep function, remove this print line, and remove this increment section as well. Everything else will remains the same. If you want, you can remove this libraries part as well. You can refactor it, then simply save the file, and now let's trigger it again, and let's see if our application is changed from running state to pause state. For that, just keep your head on this running section at the top right, at the bottom right actually, right? Just keep looking at this bottom right section. So let's trigger this, and we can see the application state is changed from running to paused. Now if you go to debugger, you can see there are multiple characters like J2, BJ3, BJ4, BJ5, BJ. There's a particular pattern in this value, and this data is available into stack pointer. So when we override the buffer, some data is also passed to the base pointer as well as the instruction pointer here. So what we're going to do, we're going to copy the base pointer value. Just go to right click, go to copy section, copy it to clipboard. Now just go back to terminal here, go back to Kali part, and here you can just go with the same module msf minus pattern, but this time instead of creating we're gonna go with another module which is offset, and then we're gonna query. So we can see we got the length of 1250 characters, and we got this value on our EBP, which is the base pointer here. When you press enter, this will give you the exact offset, right, which is the buffer size here. In this case, this 1048 is your buffer size, and we got 4 more characters for the base pointer. It means the exact offset is 1052. 1048 offset, let me just write it here, it's 1052. Now we can see application is not handling the exceptions properly, and through this we can identify the exact buffer size for this particular function which is handling our input for this IP and the port. Then we have to move to the third step, which is identify the bad characters, and the simplest method is just pass all the hex values from %00 and up to %ff. This %00 is called as the null value, and this %ff is generally called as the end of file. We call it as EOF here. So this is EOF is also a bad character which you have to identify. So instead of passing one by one, we're going to pass all of them in a single series. And to get the list, you can again go to this browser and search here for bad characters on the GitHub. You can go with any particular repository, it's completely your call. All you will get is a series of %00, %01, 02, 03, 04. Right, simple. So just copy all these characters, go back to this VS code here, and instead of passing this pattern here, this time we're gonna pass these bad characters. So let's just go back and add another character which is /x00 here, and let's save the file. But we also have to start the application once, as our application is already running here, which is not coming on the top. Let me just check why. is this user application is in pause state. So what I'm going to do is I'll simply go to debug section and I'll restart the application from here. So it will automatically load all the DLL files and create a new instance of the same application there. So we can see the application libraries modules are being loaded into the memory, and the current state is pause. As soon as it gets loads into the memory, the state will be in paused. Now just keep your eyes on this register section. I'm gonna change the state from pause to running. You can see the values of multiple registers are changed, multiple libraries are loaded, and after this we can see the application pop up on our screen. All right, application is running. Let me minimize this. Application is attached to debugger as well, and we got our script where we get our multiple bad characters, or let's say all the hex values which could be bad character, like which can contain some multiple bad character, like percentage 00 is also there, percentage ff is also there, percentage 0a 0d is also there. These are few well-known bad character, and if application crash at any particular value, then it means that value is a bad character for the application. For example, if application crash at this /x05, it means application is unable to handle this /x05. So we have to remove it from the payload. Simple. Now let's pass this data and let's see application crash or not. And if it crash, what value it crash. So for that, let's just go back to terminal, go to PowerShell, let's trigger the script, and we can see the application is still working perfectly fine. Application is still interactive and the state is still running. It means for all the hex character, there is no bad character for the application. You can pass any character to the application in your payload. But just to show you, if application crash, how you can identify the bad character from your input. For that part, what I'm gonna do, I'll simply multiply this by 5. So instead of passing this 255, I'll pass it to 1255 characters. Right, simple, which will simply flood the buffer and crash the application. So I can show you the memory dump part as well, and just to show you how to identify the bad character if the application crash. So let's save it, go back to terminal and trigger the application again. Now this time you can see the application is crashed and the state is changed from running to paused. Now if the application crash, what you have to do is go to this ESP section, right click and follow in dump. Here, this is the memory dump part, and here you can see we got the ASCII representation, and on the left hand side we got the hex representations as well. So to identify the bad character, all you have to do is just, let me expand this section. Okay, here you can see we got we got 00, which is again percentage 0 or /x0, both are the same values, just there's a difference between the representation part, but everything else is same. So note this one, yeah. So we got values from 00 and up to ff here. Now if the application crash with any uh, particular value, all you have to do is just go with the series. If you see any missing value, if you see any missing component inside this hex dump, for example, let's say if this 37 was not there, if instead of 37 you see like 55 here, on the place of 37 if you see 55, or if you directly see 38 after this 36, you see 38 here, it means 37 is the bad character and you have to remove it from your payload. Simple. So this way you can identify all the bad character and which you have to remove from your payload so you can execute your payload successfully. If your payload has bad character, it will not be executed. Simple. Now let's load the application again. Done. Let's change the state. Now this will take a while, but in the meantime, let's just okay, let's just move toward our fourth state, which is identify the address. But first of all, let's take a note of that we don't have any bad character, so no bad characters here. Done. At the fourth stage, you have to identify a particular command, which is jump esp. There are two main conditions for this one. First thing, this address should belong to application stack. The first condition. Second condition, the library from which, or let's say the like any stack, any library from which you identify this jump esp, the ASLR and safe SEH, they should be false. ASLR means it simply stands for address space layout randomization. The main objective of ASLR is it will keep randomizing the addresses for your instruction pointer, for your base pointer. It will keep randomizing all those pointers and keep updating those registers as well. So if the ASLR is enabled, as soon as you identify the address and pass your payload, it might be updated 10 times, right? So this way you will not be able to execute your payload successfully because the address that you are targeting for jump ESP is changed multiple times, right? So just to avoid it, identify a library for which ASLR and safe SEH, and this safe SEH means safe exception handling. If ASLR and safe SEH are false, it makes a bit easier for you to exploit this buffer overflow, this stack based buffer overflow here. Now all you have to do is just identify this library where safe SEH ASLR is disabled, and they should be from the application stack. You can identify it from all the libraries, or you can say the DLL files. Simple. Which are loaded by the application itself. And for this, just to get these two values, we're gonna take help from the Mona module or Mona master, let's say. This Mona module is not pre-available inside your system, so you can just go to Google and go for Mona modules. You will get a result from this github.com/corelan/Mona. Just open this one, and here you will find a mona.py file. Let's open it. And on this, all you have to do is just copy this code. You can download this file as well. All is your call. Just copy this file and then you have to move it. Let's go to this local drive C, and here you can go to program files, go to immunity incorporation, immunity debugger, and here you can see the py commands. So here you have to copy and simply paste this mona.py file. If you download it, you can directly move it here, and if you copy the code, you can create a file and then you can later move it here. Now after creating a file inside this py commands or moving it, then all you have to do is just go to this debugger section again, and this is the command palette in which you can write the commands for the different multiple py files here. So just go to exclamation, go to Mona modules and hit enter. This will give you all the libraries, all the DLL files which are loaded into the memory. They could be from the cloud application, they could be from the VS Code that I'm using, they could be from the Unity debugger as well, they could be from the multiple other application or the background processes which are running into the system itself. But this will give you a list of all the background loaded DLL files here, and all you have to do is just get a DLL file which is loaded by the application where ASLR and save SEH are false. So just wait for a few seconds and we will see the results here. All right, we got the results. Let me just scroll it a little bit. All right. I think the whole entries are not visible to us, but okay. First of all, let's see these two values. First one is save SCH, which is exception handling. Second one is the ASLR, and we can see the top two entries for the save SEH and ASLR where both are false. So just to see all the entries inside this library file, let's just go to option section, appearance, and let me reduce the font size, change, and let's take it to 9. Let's take it to 6. Done. Okay, so you can see, let me just use the magnifier here. Okay, let me copy the whole line then. Copy to clipboard, whole line, and let's move it here. Now here you can see the address is this one, the message is this one, and if you scroll here you can see the save SEH and ASLR, which are the first, second, and the third value. You can see the second and third value both are false, and if you scroll a little bit more you can see the DLL file is loaded from the CloudMe application itself, which is qt5 core.dll. So it means we can target this particular DLL file to get the address for jump ESP command. So let's do it. So the library that we got, let me just write it here. So one more thing, always take notes for all the steps that you perform. So the library is qt5 core.dll. Now ASLR and SafeHH both were false. The third thing we have to look for is the address. Let me just note down the commands as well so you can later refer them. So the command is exclamation mona modules, and you can see the same value in the output. And for the address, now let's figure out the address from this qt5 core.dll library. And for that we're going to use the mona again. So let's go to mona, go in the find command this time, that we are looking for something, but what we are looking for is the jump ESP. If you want, you can specify its hex representation as well, which is /xff/xe4 here. Then you can go with -m, that where you want to identify this jump ESP command. So I want to identify this from the qt5 core.dll, not code.dll file, and let's press enter and wait for the results. You will see a list of all the pointer that points to jump ESP command. All right, let me scroll to get the results. Done. Okay, so here you can see we got multiple results, like we got around 55 results, and out of 55 only few of the results were listed here. If you want, you can list more again, but I believe most of them, or you can say all of them, will work for your buffer overflow. So here all you have to do is just copy this pointer here. This is the pointer address that points to jump ESP command. So just take a note of it. Let's just go to this VS Code and take a note of which is 0x, and 68E05735. One more thing, if this particular address doesn't work, then you can go with another one, which is, just take a note just for the reference, 68E05D and E1. So we take two addresses here. So I think any one of these two, or let's say all two of them, will work here. Now we got the address, we got the bad character, we got the offset size. All we need is the payload. So after this, just you can close this Mona module or close this entire debugger as well, because we are done with the debugger, we are done with the Mona as well. So let's simply start this CloudMe as a normal application. We don't have to attach it with the debugger this time because we're going to pass the payload. So let's just go to Kali Linux here. And to create the payload, again, I'm going to use MSF Venom. And for the MSF Venom, you can specify your payload. Like I'm going to use VNC inject, reverse TCP, whatever payload you want to use, you can use it. All is your call. But because we are performing a local buffer overflow, we don't have to specify this lhost and create the exe file and all. But instead of that, what I'm going to use is MSF Venom -p. I'll go with Windows CMD. So if you want, you can go with another tab and you can look out for the payloads as well, or you can take help from this one as well. Just go to exploit db. In local buffer overflow, we generally prefer executing local commands instead of executing a malware there. We simply prefer starting a CMD kind of thing, or let's say the calculator kind of thing, or MS Paint kind of application. If we are able to execute those system OS commands, or if we are able to trigger the application, it means we have successfully exploited the buffer overflow there. So if you just go to this section, from here you can take help from this payload part. If you want, you can specify this lhost, lport kind of thing, but we don't actually need this one, right? So if you just go to Google, for this one they have used the reverse TCP for the different application, but you don't actually need it that, right? So just go to google.com and just search here for MSF payload for CMD, or let's say calculator. To start calculator, simple. Just go to generating section, payload generation. You can go to shellcode for MSF PNM. You can refer anything, simple. Or you can directly go to this section, and here, because my SSH connection is not working properly here, so let me just go this Kali Linux and let's directly search there for the MSF payloads first. Go with the password, and let's start searching with MSF Venom. If you want, you can list all your payloads and you can grab for something as well. So instead of grabbing directly CMD, I'm gonna grab this Windows/exec just to execute our local system commands. You can use this payload here. So this says you can execute your arbitrary command. If you want, you can list out other payloads as well, and you can simply use any one of them directly there. So as we got the payload, all you have to do is just go to this MSF Venom, then go to -p, then go with the payload as Windows exec, then go with CMD. Don't go with this space here, it's just a TTY error there. Just go to CMD and go for any particular command that you want to execute. So I'll go with calc.exe. You can execute any command because I'm targeting this calculator here, so it will trigger the calculator directly. Then I'll go with -f, and I want a code of C language, and let's hit enter. Not format, I want okay, no worries. Okay, it will also work. So let's simply copy this one, copy, And now let's paste it within our, okay, let me remove this one. Okay, let's take junk as a multiply by 1052. We're gonna pass 1052 as, then we're gonna pass the EBP, which is the address, then we go gonna pass the payload. Done. Let's pass the payload here. And one more thing, always keep in mind, if you simply add this line, right, it will only pass this section of the payload to your victim. The rest of the payload will not be passed. So all you have to do is either enclose it within the circular bracket, or you can go with payload plus equal to kind of values. Like for example, copy and you can paste it here and go with a plus section as well. Go with payload plus equals to this. So you can add all of your payload in the variable and then you can pass it to the victim. Now I'll create another variable which is data equals to first we will pass the junk, then we will pass the EBP, and then we will pass the payload. So if you go with the classification here, this junk will be passed to buffer, then we got the EBP part which will be passed to EBP itself, then we got the payload which will be passed to ESP and gets executed. Now we got the data, we got the payload, we got the junk. The only thing which is left is the address. We got the address, but if you want to pass this address, you have to reverse it, because the address is always in the big endian format. So you have to convert it into the little endian and then you have to pass it. So let me just convert it, and just to convert, you just have to flip it. All you have to do is just flip it, right? So we got slash x 35, then we got again slash x 57, then we got slash x e0, or we got slash x 68. So just create pair of two values because hex values are represented into a pair of two, and this is our actual address that we're gonna pass. Copy it. If you want, you can create the same for the second value as well. So just go with e1 slash x e1 slash x5d, x was missing, and slash x e0, then we got slash x 68. Simple. Now just copy the first one, let's see if it works or not. Copy it, pass it to the base pointer and save the file. All it will do is it will send the data. In data we have the junk which will flood the buffer and the base pointer. Because we have added a base pointer here, we just name it as EIP because we are passing the EIP instead of EBP. This value will be passed to EIP, the instruction pointer, not to the base pointer. So this junk will be sent to buffer and the base pointer. This EIP value will be passed to the instruction pointer. Then the payload will be passed to the stack. Instruction pointer will point to the jump ESP. It will jump to the stack pointer. Then our payload will be stored into the stack pointer again. Simple. Now let's save the file and let's try executing it. Fuzzing.py. If everything runs perfectly, then we will see the calculator here. Application is closed, and in the background you can see we got our calculator. It means our application is vulnerable to local buffer overflow, and we can simply exploit it, or we can execute the remote commands as well. But for the remote command, for the remote buffer overflow, all we need is the application opening a port on all the IP addresses which it has. It could be a local IP address as well, it could be IP from the router as well, it could be IP from other interface as well. If application is exposing its port on the interface which is available to public, then we can perform remote buffer overflow. Otherwise, if application is exposing their port on localhost which is 127, in that case we can only perform the local buffer overflow, right? But again, local buffer overflow is slightly less deadly if we compare it with the remote one, because for the local one you need a malware on your local system first, then that malware will take advantage, or let's say somehow pass the payload to the victim application, then it will get the shell. Simple. For the shell part, all you do is just change this payload for the shell. So you can just go to Kali Linux, or you can go here and search for a payload which will give you the reverse connection. Simple. So just by changing the payload, you can easily get a reverse connection as well. Simple as that. This is our local buffer overflow, and you can take it to the remote part as well. Simple as that.